Hey everyone, and welcome to Edritt. So this lecture is about giving you an introduction of what we are going to study in this course curriculum, which is digital electronics. Okay, so this is the syllabus which we are going to cover. So first of all, we'll understand the introduction to digital electronics. Basically, we will see, what digital electronics actually means. What is analog signals, and then what are digital signals. All the real world signals are analog signals, and why do we need to convert those analog signals to digital signals? Because we have limited size available to store, not the infinite size. And how do we convert those signals using the sampling and concept of quantization? We'll just quickly see through it, and then later we'll study those things in detail. And then after that, we'll move to the other concept, which is number system. So in number system, we'll see different radix number system like binary, decimal, octal, hexadecimal. We'll do different operations on them, like converting from one number system to other number system. Decimal is something which we are more comfortable on. So converting from any number system to decimal number system, or from decimal number system to any other number system. We'll see different things over there. Once we are done with that, we'll move to logic gates part. So what is this logic gates part? We'll see what kind of logic gates which we have available, like AND or NAND nor XOR, XNOR, implication, inhibition logic gates. We'll see the concept of universal logic gates, how we can make all sort of logic gates using universal logic gates, etc., etc. And then we'll move to the part of Boolean algebra. Once we are done with Boolean algebra, we'll move to the combinational circuits part. Okay. So in that, we'll study different sort. First, we'll understand what is combinational circuits, and then we will move to the, different set of combinational circuits. We'll make some standard combinational circuits like half adder, full header, half subtractor, full subtractor, and then multiplier, parity detection logic, etc. Once we are done with all these standard combinational circuits, we'll move to the understanding of programmable logical devices. Okay, so these programmable logical devices are basically memories. We will study about them, and then we'll move to the sequential circuits part, which is basically your flip-flops and latches. Okay, so we will study what are latches, what are the issues with them, and then why we need flip-flops, why flip-flops are edge sensitive instead of level triggered, and then we'll see uh, different sort of flip-flops like SR flip-flop, JK flip-flop, T flip-flop, D flip-flop, their operations, their applications, and then different things like what are FSMs, what are shift registers, etc., etc. Once we are done with that, most of the digital part is complete, and then we will move to some small topics like data converters. Now here we will study in depth about the analog to digital and digital to analog converters, how we can convert from one to another. Okay, so we'll read different things here as well, R to R ladder, and then SAR registers, etc., etc. Once we are done with that, we'll see the logic families which are available, like the RTL, DTL, TTL, um, I square L, etc., etc. We'll see what are CMOS. Okay, and then once done with this, we'll see what are memories and how do we design memories. Okay, so this will complete your whole course curriculum, and this curriculum will be useful if you are preparing for college placements, or either you are preparing for VLSI placements, okay, or either you are interested in some competitive exams like GATE or engineering services examination. Anyway, if you are eager to know and understand digital electronics, this is the right place for you. So with this, we'll end this lecture, and I hope I'll see you in the next one. Thank you.